he's ever done. So it's my pleasure to introduce the man who's behind it all, Dan D'Agostino.
If you pardon me for a minute, I'm going to read off my iPhone the English definition of relentless. Persistent, constant, continuous, nonstop, never-ending, unabating, interminable, incessant, unceasing, endless, unending, unrelenting. Yes, I'm all those things when I designed this amplifier. You know, the concept of this was in my head for a while, but I've never had the opportunity to completely finish it. And about 2 years ago, I started on that quest, and I brought in all of my skills at building and designing a circuit, which I did. And then I brought in my engineering team, Director of Engineering Mike Koza, and a 50-year veteran that works for me, Bill Hughes, and Jack Krebs, who's one of our digital designers, and all of us put our heads together to make this thing work. So let me tell you a little bit about it. You know, there's other balanced amplifiers on the marketplace, and they all achieve sound. They all achieve great power because with balance you can get 4 times the voltage you get on single-ended. Well, here's the dichotomy. There was a paper written a while ago on balance, and nobody's really made, until now, a truly balanced amplifier. And the reason why I say this, in order for it to be really truly balanced, each half of the amplifier, the positive and negative side, have to be exactly, and I mean exactly, opposites of each other. So how do you do that? This is the question. This is a big question. How do you do that? And this is what we accomplished. And that's why it took 2 years to get it to work correctly. So now we have an amplifier that has very low distortion without global feedback, because all of the distortion products are mixed together with the negative and the positive, which are exact reciprocals of each other. And they null out all the distortion products. So this at full power is 0.006. You know, a momentum's 0.1, which is marvelous. And this amplifier would be 0.12 if it wasn't a perfect balanced amplifier. We do not have global feedback, so there's no way to change that. So that's what we get just by adding the 2 sections together. We also get incredible signal-noise ratio. We get incredible dynamic range. We incorporate the super rails that we incorporated in the momentum and in the progression amplifiers. But we incorporated another step where we actually have a step inside the super rail to work this amazing front end. The front end operates independently of any other part of the amplifier. In fact, it doesn't even know that it's an amplifier. It works in its own little space. It's an enigma. It just sits there. And no matter what the output stage does, no matter what demanding program material you put on this amplifier, the front end and that perfect mirror never changes. And that's the magic of this amplifier. Along with an extraordinary quiet power supply, we have a multiple domain power transformer that's laminated in a certain way to make it have no noise. And then it's surrounded by wraps of silicon steel, and then it's potted into a steel can so that it's totally quiet electrically and mechanically. It's got 600,000 microfarads of capacitance in the old way, where the big can capacitors that you don't see so much anymore because they're so expensive, but they have their own problems. They resonate. They're big hollow cavities. So we have an acoustic damper built in that clamps them in and grounds them to the chassis so they're dead quiet. And that's coupled with big copper bus bars. And I tell you, because I come from an era when we built big amplifiers, we used big copper bars, and that's what this amplifier has in it. It's got 100 output devices. It's got 32 drivers. It's got 60 pre-drivers. It's a very complicated amplifier in many ways. But what it does is it makes for an output stage that delivers more current than anything we've ever designed, and I've ever designed in my history. And I've never seen anything that can do what this does. If you put it at full power at 8 ohms and you run it into 2 ohms, the voltage on the output stage doesn't change, which is really significant. So this has a tremendous power capability. It's got an amazing lightness and musical quality that's never ending. It has over 100 watts of Class A at idle. So all the low-level signals and all of that are never lost. So it's also something that could be ran on almost any kind of household current. I'm telling you, you're not going to put 6,000 watts into 2 ohms with 110 volts. But it will turn on and it will play perfectly fine. It won't dim your lights. It's got a very special soft start circuit in it. So going to the mechanical design, you know we use copper in the momentum. I wanted to make a statement with that because copper is a very important part of the momentum. So in the Relentless, I use copper differently. I turned it into a heat engine. So it's really the copper gets warm, the heat sink on the outside gets rid of the heat. We took the Venturi effect that we have in the momentum heat sink and we made it into a more complicated Venturi for the outsides of this mechanical heat sink. So this thermal engine, as I like to call it, is constant. It gets to one temperature and it almost will never change. And I've had them in my house on for 2 weeks and I've played them at crazy levels and low levels and they're always the same temperature. I mean, they rarely rise in temperature. That's a very important thing. It's got fully protected, so if you short it out or any mishap, it won't damage your speakers. It backs out very fast. It's got the meter. Now the meter is a whole nother thing. As you can see, it's got 260 degrees of swing. So how do we move a meter like that? Well, we have a meter with a multiplier in it, so that at low levels you see it moving. But as you play it higher, it starts to swing, and it's got acoustic dampening in it. So it's got sustain, so it comes up and it rests and it goes back and forth, and you'll see it at big crescendos. I haven't gotten it to go all the way up to 1.6 yet, because I only have Wilson Alex's, and I don't want to break them. But I had them at Dave Wilson's house about 2 weeks ago, and I wasn't in the room when Daryl did it, but apparently he had it way up there in the 1.2, 1.3 area. I think Bill McKeegan's a witness. But I was outside talking to one of Dave's friends. But it's fully capable of doing anything you like, and it is an acoustic marvel. So with that, I'd like to open the floor for any questions. Yes, sir.
Do you have a projected retail price?
Yes, the retail price is $250,000 a pair, and we'll be delivering in July. I did talk about the heat, but the binding post I didn't say. We have a special binding post made in the back. You know, I get really tired of binding posts because you get a spade lug, you put it on, you twist it, and it spins around. It never tightens right. The tines bend. So I made a binding post that really isn't possible. If you walk around the back and take a look, you can see that it's got a washer and a spacer, and it's got cuts on the side of it. So when you put a spade lug on it and you tighten it, it won't spin. And then you can tighten it as tight as you want. It comes with a carbon fiber socket and a hand ratchet. So you can tighten it nicely, and it basically won't bend your tines. And I'm not a big binding post fan. That's why I spent a lot of time designing this, making sure that when you tighten something on it, it stays tight and it doesn't move around. It doesn't ruin the binding, the speaker lug when you tighten it. On the finishing, this is all diamond cut. The copper's cut and then coated in a synthetic enamel. And the heat sink itself, as I said, is actually an extrapolation of a Venturi. So if you look at it, you can see how it works. And it spins the air around the fin and then out the top. So it's a very intricate design. You'll notice the faceted part of the amplifiers are all matched up in the machining. So this was done to be a piece of jewelry, but a big piece of jewelry. So, any other questions?
What is it weigh?
It's around 500 pounds. Give or take 100. No, give or take about 5 pounds. 10.
And how do you package this? How
This
does
is
it-
packaged in a great big wooden crate. We wanted to put it in a Pelican case. They don't make a case this big, but then Patrio's son Alex pointed out to me that you can't take it out of the Pelican case because it weighs 500 pounds. So we had to have a case that came in 2 parts. So you basically get it on a plinth. You take the cover off, there's lift holes in it, you can pick it up. 4 guys can pick it up and set it down, either on a dolly or whatever you want, and wheel it to where it's got to go. It's got 307 hardened stainless steel feet on it that are rounded instead of pointed. Because I figure no matter what kind of floor you put it on, it's going to break it if you have a point on it. So I made a rounded foot that it sits on. So that's, yes,
It's biased Class A.
it is not Class A. It's Class AB, but about a little over 100 watts is Class A. Just at out here.
Are we looking at just one channel?
This is
or are
one
there
channel.
Two boxes per channel?
You get 2 boxes for $250.
That's right.
You throw one in. You buy one for $250, the other one for $250.
Then this is for a huge speaker. What is the target that you mentioned?
You know, we think that any speaker will work great with it. I've had it on a pair of speakers that are like $20,000, and I've had them on my Alex's at home, and I've had them on Dave Wilson's Whams. Clearly, if you have a pair of Whams, this is the ultimate amplifier for it. But any speaker, a Magic OM6 would be an awesome match for it. Any of the big speakers out there, this would be great. But if you just like the big amplifier and smaller speakers, this is 100 watts of Class A. The small speaker, you're never getting out of Class A.
What's the power in Class AB?
It clips at about 1,640 watts. We rate it at 1,500. It'll put out a good solid 6,002, and we don't have enough power in our factory to measure it in the watt.